Okay, we're finding the area of this shape. There's already been one video file of about 7 or 8 minutes which has explained how we've got here. We're trying to find the area now inside this shape. Now you need to split the shape up into two. We need to do to the left of here, because that is involving that curve and that curve. But here it changes. This curve no longer has an impact over here, it's a different one. So first of all we're going to find that area, and after that we're going to find this area. Now to earn the area between curves, you integrate. So we're going to integrate, and when we're doing between two curves, you need to integrate the equation of the top curve, take away the equation of the bottom curve. I'm just going to put the dx there. This isn't sort of proper notation, but you get the idea of what's going on. Now we've already worked out earlier on that the equation of this curve here is y equals x into x plus 3. We've already worked out that this bottom curve here, the equation of that one is y is x minus a quarter x squared. So to the left of this vertical line, which is crossing the x-axis at 1, I'm going to be finding the difference between these two curves. So I'm going to integrate. The top curve is x multiplied by x plus 3, and the bottom curve is x take away a quarter x squared. I need to put all of that in brackets. I need to put my dx there because I'm integrating with respect to x, and my x values I'm going between are 0 and 1. So those are my limits. So that's the integration I've got to do. So continuing with this, before we do any integrating, we might as well multiply it and simplify. So between 0 and 1, I have here x squared plus 3x minus x minus minus, that makes plus a quarter x squared. The dx is still there. Carrying on, how many x squareds have I got? 1 there, another quarter there. That's 1 1/4, or 5 quarters x squared. And here I've got 2x. So that is what I've got to integrate. When I integrate, I add 1 to the power and I divide by the new power. So when I integrate 5 over 4x squared, I'm going to get 5x cubed over 12. And put a multiplying sign or a dot there to show they're being multiplied together. When I integrate 2x, I add 1 to the power. And think of there's a 1 there already. Add 1 to the power, divide by the new power. Put it in the rectangular brackets to show it's been integrated, but I still need to put these limits of 0 and 1 in. So, just simplify this. I've got 5x cubed over 12. Take away, they cancel out, x squared between 0 and 1. So what I've got to do now is substitute in 1 for every x value. So the first bracket, be 5 lots of 1 cubed. 5 lots of 1 is just 5 over 12. And then here, take away 1 squared. So that should be a plus sign there. There should be a plus from here. So here, 1 squared is 1. So I've got 5 12ths plus 1. When I substitute 0 in, I'm going to get 0 and 0. So that's actually going to give me nothing at all. So 5 12ths plus 1, 1 and 5 12ths. That's the area of the left-hand part of that graph. So now we need to look at the right-hand part of the graph. So let's look at the graph again. We're now trying to find this area here. So this time I need the equation of this curve. The equation of this curve we already know is y is x squared minus 6x plus 9. That's the top curve, and I've got the bottom curve. So, following the same process as last time, I need to integrate the equation of the top curve minus the equation of the bottom curve. Whole equation needs to be in brackets. My dx needs to be there. Now, the x value here is 2, and I'm integrating this between 1 and 2. So that was top curve, take away bottom curve, and this is applying between 1 and 2 on the x-axis. So, I've now got to do this integration, straight in the paperwork. So, first thing to do here is try and simplify what we've got. So I'm integrating between 1 and 2. I have an x squared here and a negative negative, which will make a plus quarter x squared over here. So altogether I've got 1x squared plus a quarter x squared. That's 1 1/4 or 5 quarters x squared. X's, I've got negative 6x here, take away 1x, so that takes me to minus 7x. I've still got my plus 9, so this is what I'm integrating in this part of the question. So remember, when you're integrating, you add 1 to the power and divide by the new power. Those are being multiplied together. There's a power of 1 there, so add 1 to the power, divide by the new power. With the 9, you can think of that as 9x to the power of 0. So when you integrate it, I will add 1 to the power and divide by the new power. I will get that. That x to the power of 1 is just x. Dividing by 1 doesn't do anything. The quick way of thinking is when you integrate a number, it's just a number and the x. In the square brackets between 2 and 1. Now I need to substitute those values in. So, when I substitute the 2 in, 2 cubed is 8. So I've got 5 lots of 8 over 12. Here I've got 7 lots of 2 squared over 2 and 9 lots of 2. Then I need to do the same thing with the 1. 1 cubed is 1, so this will just be 5 over 12. 1 squared is 1, so I get minus 7 over 2, plus 9 lots of 1, that's just 9. So I've got here 40 over 12, take away 28 over 2, plus 18, take away 5 twelfths, minus minus makes plus 7 over 2, and minus plus makes minus 9. And when you simplify all that, just work out the value of that, you get, again, 1 and 5 twelfths. So, going back to our graph, I actually have this area is 1 and 5 twelfths. This area is 1 and 5 twelfths. So the total area is 1 and 5 twelfths. Add another 1 and 5 twelfths. So that's going to be 2 and 10 twelfths, or cancelling down, 2 and 5 sixths. And that is the combined area of that shape. Quite a tricky question though for AddMaths, a lot involved in it.